Corner tapping the 480-volt secondary provides a ground reference for the equipment. This is achieved by creating a neutral point on the 480-volt secondary, which is then connected to the equipment's grounding system. This ensures that faults and transients are directed to earth. According to National Electrical Code Article 250.24, b. A ground reference must be provided for equipment operating at over 150 volts to ground. Corner tapping the 480-volt secondary fulfills this requirement. Providing a ground reference significantly reduces the risk of electrical shocks and enhances safety for personnel working on or around the equipment. Functionally, corner tapping a 480-volt delta transformer is equivalent to using a 480-volt Y transformer, as both methods create a neutral point and establish a ground reference. Compared to installing a separate 480-volt Y transformer, corner tapping proves to be a more cost-effective solution. It leverages the existing 480 to 208/120 volts transformer, eliminating the need for additional equipment purchases. Corner tapping is an accepted practice in the electrical industry for establishing a ground reference for equipment powered by delta-connected transformers. It's understandable that inspectors might have concerns about the absence of a ground potential on the secondary side. However, corner tapping effectively addresses this issue, aligning with the intent of relevant codes and standards. To effectively communicate the solution, 1. Clearly explain the concept of corner tapping and how it generates a ground reference. 2. Reference the relevant National Electrical Code articles that support this practice. 3. Emphasize the safety advantages and cost savings linked to corner tapping. And 4. Share real-world examples of successful implementations of this technique in comparable scenarios. Now let's delve a bit deeper into each of these aspects. Firstly, to explain the concept of corner tapping and how it generates a ground reference, start by describing a delta-connected transformer. Explain that in a delta configuration, the three windings are connected in a closed loop, resembling a triangle or the Greek letter delta. Normally, none of these points are grounded. However, in a corner-grounded delta system, one of the phase conductors is intentionally connected to ground. This connection establishes that phase conductor as the grounded conductor, effectively creating a ground reference for the system. Emphasize that this ground reference allows for the detection and mitigation of ground faults, ensuring that any unintended contact between a phase conductor and ground will result in a high current flow, tripping a circuit breaker or fuse and energizing the circuit. Explain that this is a critical safety feature. Secondly, in order to reference the relevant National Electrical Code articles that support this practice, direct the inspector to Article 250 in the National Electrical Code, which covers grounding and bonding requirements. Specifically, reference Section 250.24. b. Which mandates a ground reference for equipment operating at over 150 volts to ground. Explained that corner grounding a 480 volts delta system is a permissible method under the National Electrical Code to meet this requirement. Additionally, cite Section 250.4. 8.1, which discusses grounded systems and their role in limiting voltage due to lightning, line surges, or unintentional contact with higher voltage lines. Explain that corner grounding contributes to this voltage limitation. Thirdly, in order to emphasize the safety advantages and cost savings linked to corner tapping, highlight the safety benefits of corner grounding, such as reduced risk of electrical shock, improved equipment protection, and enhanced safety for personnel. Explain how corner grounding facilitates the prompt detection and clearing of ground faults, minimizing the duration and severity of potential electrical hazards. Compare the cost of corner grounding to alternative grounding methods, such as installing a 480 volts Y transformer. Emphasize that corner grounding utilizes the existing transformer, eliminating the need for additional equipment purchases and reducing overall project costs. Quantify the cost savings associated with corner grounding. Share the cost difference between corner grounding and installing a new Y transformer, including the cost of the transformer itself, as well as any associated installation labor and materials. Fourthly, in order to share real-world examples of successful implementations of this technique and comparable scenarios, provide examples of other facilities or applications where corner grounding has been successfully implemented. This can include industrial plants, commercial buildings, or other similar installations. If possible, provide data or testimonials demonstrating the effectiveness and reliability of corner grounding in these applications. Gather information on similar projects where corner grounding was used. Contact engineers or electricians who have implemented corner grounding in the past and ask if they would be willing to share their experiences or provide a reference. If you have implemented corner grounding in previous projects, document the process and results. Compile photos, diagrams, and data to showcase the success of the installation. Explain the specific steps involved in implementing corner grounding, including selecting the appropriate grounding conductor, making the necessary connections, and testing the system to ensure proper operation. Provide a detailed wiring diagram showing how the corner ground connection is made. Include information on the size and type of grounding conductor required. Describe the testing procedures used to verify the integrity of the ground connection and the effectiveness of the grounding system. Be prepared to address any concerns or objections the inspector may raise regarding corner grounding. Anticipate potential questions and have well-reasoned answers ready. For instance, the inspector may be concerned about the potential for circulating currents in the grounding system. Explain that these currents are typically minimal and do not pose a significant risk. The inspector may also be concerned about the stability of the ground reference. Explain that the ground reference is stable as long as the corner ground connection is properly maintained. With clear explanations, supporting documentation, and real-world examples, it's possible to address the inspector's concerns and gain approval for corner grounding as an acceptable solution. To summarize, corner grounding of 480 volts delta transformer is a code-compliant, safe, and cost-effective method of providing a ground reference. By understanding the principles behind corner grounding, referencing the National Electrical Code, and communicating the benefits effectively, one can confidently address the inspector's concerns and gain approval for this grounding method.